हमें इस क्वेश्चन में दिया है कि एन इंजन हैज एन इफिशियंसी ऑफ 1/6 एंड व्हेन द टेम्परेचर ऑफ द सिंक इज रिड्यूस्ड बाय 62 डिग्री सेल्सियस देन इट्स इफिशियंसी इज डबल्ड। देन हमसे पूछा है कि टेम्परेचर ऑफ द सोर्स क्या होगा। ठीक है, तो यहाँ पे दिया है कि पहले इफिशियंसी कार्नोट इंजन का क्या है 1/6 है। अब टेम्परेचर जो सिंक है इसका क्या किया 62 डिग्री से रिड्यूस कर दिया गया। तो अब हमें बोल रहा है कि जो हमारा इफिशियंसी है डबल हो गया, तो हमें बताना है कि टेम्परेचर ऑफ द सोर्स क्या है। तो देखो ये हमारा होता है सोर्स, ठीक है, और ये हमारा होता है सिंक। ठीक है, इसको हम बोलते हैं टेम्परेचर ऑफ द सोर्स और इसको हम रिप्रेजेंट करते हैं T1 से, और ये हो जाएगा टेम्परेचर ऑफ द सिंक और ये होता है हमारा T2। ठीक है, और ये T1 T2 जो टेम्परेचर ये होते हैं हमारे केल्विन में। ठीक है, ये होते हैं हमारे केल्विन में। ठीक है, तो जो इफिशियंसी होता है कार्नोट इंजन का इन टर्म्स ऑफ T1 एंड T2, इसका फॉर्मूला होता है एफिशिएंसी ऑफ कार्नोट इक्वल्स टू 1 माइनस ये होता है हमारा T2 अपॉन T1। ठीक है, यहाँ पे T2 किसका टेम्परेचर है, ये है हमारा सिंक का, और T1 जो हमारा सोर्स का। ठीक है, ऑब्वियस बात है ये हॉट सोर्स होता है, ये कोल्ड होता है। ठीक है, तो तभी तो यहाँ से इफिशियंसी हमेशा 1 से कम होगा, तो ये T1 हमेशा ही ज्यादा होगा T2 से। ठीक है, अब यहाँ पे दिया है कि जो इफिशियंसी है हमारा दिया है 1/6। इनिशियल कंडीशन में हमारा इफिशियंसी इक्वल टू 1/6 दिया है, तो हम इसको इधर ले आ जाते हैं, तो यह आ जाएगा T2 अपॉन T1 इक्वल टू 1 माइनस n, और ये इसका इफिशियंसी दिया है 1/6 इनिशियल कंडीशन में, तो यहाँ से आ जाएगा T2 अपॉन T1 इक्वल टू यहाँ से 6 है तो 1 माइनस 1/6 करेंगे तो कितना आ जाएगा, ये आ जाएगा हमारा 5/6। ठीक है, तो ये आ गया हमारा इक्वेशन 1। ठीक है, अब ये क्या कर रहा है, अब इसको हमने टेम्परेचर जो सिंक का है उसको 62 डिग्री से रिड्यूस कर रहे हैं, तो इफिशियंसी डबल हो रहा है। इसका मतलब इफिशियंसी डबल हो रहा है, पहले 1/6 था, अब इसको डबल कर दिए तो कितना आ गया 1/3 हो गया। ठीक है, तो यहाँ से हम लिख सकते हैं जो n डैश होगा ये आ जाएगा 1 माइनस T2 माइनस 62 डिग्री से इसको रिड्यूस कर दिया गया, मतलब पहले T था T2 था, तो अब कितना होगा T2 माइनस 62 डिग्री। ठीक है, तो इसको लिख सकते हैं T2 माइनस 62। ठीक है, डिवाइड बटे ये कितना आ जाएगा हमारा T1। तो देखो हमने यहाँ पे 62 डिग्री सेल्सियस डायरेक्ट पुट कर दिया। अब देखो यहाँ पे केल्विन में पुट करना था क्योंकि हमारा जो T1 T2 है टेम्परेचर केल्विन में है, बट हम जानते हैं यहाँ पे हमने क्या लिखा है, डिफरेंस लिखा है, 62 डिग्री सेल्सियस से हमने इसको रिड्यूस कर दिया है। ठीक है, तो हम जानते हैं डिफरेंस अगर सेल्सियस में करेंगे या फिर केल्विन में करेंगे दोनों का ही इक्वल आता है। ठीक है, तो ये हमारा अब ये टोटल क्या रिप्रेजेंट कर रहा है, केल्विन में टेम्परेचर रिप्रेजेंट कर रहा है। ठीक है, तो डिफरेंस हम डिग्री सेल्सियस में लिखे या फिर केल्विन में बराबर होता है, और यहाँ पे हमें दिया है 62 डिग्री सेल्सियस, इसलिए हमने डायरेक्टली पुट कर दिया क्योंकि हमारा डिफरेंस डिग्री सेल्सियस में हो या फिर केल्विन में बराबर होता है। ठीक है, तो यहाँ से अब ये रिप्रेजेंट करेगा हमारा केल्विन में, तो यहाँ से हम n डैश हमें दिया है, हमने यहाँ पे कैलकुलेट किया, ये डबल हो जा रहा है तो ये आ जाएगा 1/3। अब यहाँ से इसको हम लिख सकते हैं T2 माइनस 62 डिवाइड बाई T1। ठीक है, अब इसको लिख सकते हैं हम 1 माइनस 1/3, तो ये आ जाएगा 2/3। ठीक है, तो ये आ जाएगा T2 माइनस 62 इक्वल टू 2/3 टाइम्स T1। ठीक है, अब हमें क्वेश्चन में हमें निकालना है टेम्परेचर ऑफ द सोर्स, मतलब हमें T1 निकालना है। ठीक है, तो यहाँ से हम T2 को पुट कर देते हैं, इसमें कितना है 5/6 टाइम्स T1। अब इसको हम इसमें पुट कर लेते हैं। ठीक है, तो ये आ जाएगा 5/6 टाइम्स T1 माइनस 62 इक्वल टू 2/3 टाइम्स T1। अब यहाँ से T1 को कॉमन ले लेते हैं। ठीक है, तो इसको लिख सकते हैं 5/6 माइनस, अब इसको क्या लिख सकते हैं 4/6, हमें ऊपर नीचे 2 से मल्टीप्लाई कर दिया तो ये आ जाएगा 62। ठीक है, अब यहाँ से ये कैलकुलेट कर लेंगे तो T1 इक्वल टू आ जाएगा, देखो अब ये नीचे एलसीएम 6 है तो 5 माइनस 4 कितना है 1/6, ये आ जाएगा 62। अब ये T1 हमारा रिप्रेजेंट करेगा केल्विन में, तो T1 इक्वल टू आ गया 62 इंटू 6, ये क्या है केल्विन में। ठीक है, तो अब यहाँ से मल्टीप्लाई करते हैं 6 इंटू 2 12 और 36 इंटू 36 प्लस 1 37 केल्विन। ठीक है, अब यहाँ से आ गया T1 आ गया 372 केल्विन। ठीक है, अब हमें क्या करना है, हमें डिग्री सेल्सियस में चेंज करना है, तो डिग्री सेल्सियस हम जानते हैं 0 डिग्री सेल्सियस जो होता है हमारा ये कितना होता है 273 केल्विन के बराबर होता है। तो अब इसे हमें डिग्री सेल्सियस में चेंज करना होगा, तो हम क्या करेंगे 273 माइनस कर लेते हैं, तो ये 372 माइनस 273 और ये रिप्रेजेंट करेगा हमारा डिग्री सेल्सियस। ठीक है, जब भी हमें केल्विन को डिग्री सेल्सियस में चेंज करना होता है हमें 273 माइनस कर लेना होता है। ठीक है, तो यहाँ से देखो 12 में से 3 जाएगा, कितना जाएगा 9, और ये बचेगा हमारे पास 36, 36 में 27 गया 9, तो ये आ गया हमारा 99 डिग्री सेल्सियस, ये आ गया हमारा टेम्परेचर ऑफ सोर्स T1। ठीक है, तो ये आ गया हमारा क्वेश्चन का आंसर। अब यहाँ से हम ऑप्शन देख लेते हैं, तो ये हमारा डी ऑप्शन इस क्वेश्चन का आंसर होगा।
Hello students, the question for today is the sample of an ideal gas is taken through the cyclic process A, B, C, A and shown in the figure. Now you can see that the figure is showing the cyclic process. A graph is plotted up between pressure versus volume, right? Yeah, the change in internal energy of the gas along the path CA is minus 180 joule. So from C to A, they have given us the change in internal energy is minus 180, and the gas absorbs 250 joules of heat along the path AB, and they are saying 60 joules along path BC. The work done by the gas along the path ABC is, so they're asking what is the work done along the path A to B and B to C put together. Okay, so let us try to solve this questions. Okay, so now here this question is being asked from the chapter of thermodynamics, and we have the relation between the change in internal energy and work done, okay, and everything. So let me give you the formula that we'll be using for the question is change in internal energy, which is delta U, okay, plus the work done is delta W is equal to delta Q. Okay, now let me tell you that delta U stands for change in internal energy, delta W stands for the work done, change in work done, and delta Q stands for the internal heat. Okay, that is the heat given to the surroundings. Now, having understood these terms individually, we are going ahead and trying to find out what is given in the question. So in the question we have seen that the internal energy of the gas along the path has been given. So delta U is being specified from which path? The path CA. That means from C to A it is being specified. But according to the graph, you can see that C to A it has been mentioned, right? So C to A is equal to how much they have given? They have given negative 180 joules. So if C to A is minus 180 joules, then students, can you tell me what will be the change in internal energy from A to C? That will be in opposite in the opposite in the direction. That is, it is going to be plus 180, right? C to A is minus 180, then A to C, that is the opposite, has to be plus 180. Okay, it's not A to A, it is A to C. So A to C will be plus 180. All right. Yeah. Now we are going to use this change in internal energy is a state function. It's very important to know that. Okay, and now we are going to apply the formula, apply the parameters that we have. So let us try to do that. So the total exchange of heat to the surroundings delta Q from A to C is equal to delta U again from A to C plus delta W from A to C. That means the total heat transfer to the surroundings, from A to C, the process when the gas changes from A to C is equal to the summation of change in internal energy from A to C for the gas and change in the work done from A to C for the gas. Now this is given by the second law of thermodynamics. So we try to use this. Okay. Now we are going to apply the values here accordingly. Okay, so the system A to C is not a single system. It is a system. By the time the gas changes goes from A to C, there is an in between point, which is the B point, right? We need to note that, because directly the gas is not going from A to C, right? It is going through the point B also, so we need to consider that. So therefore the change in the heat, okay, to the surroundings when the gas is undergoing its the path from A to C, the change in path. Okay, so we need to mention the in between point B also. So that is delta Q from A to B plus delta Q from B to C. Okay, now I have covered. This is the total change in heat to the surroundings. So I need to consider both these things from A to B as well and from B to C as well. So these two put together will give you the total from A to C. That is equal to change in internal energy from A to C. We have found out that it is plus 180 joules. Substitute, so it is 180 plus the work done. Now the work done is what we need to find out, right? So keep it as it is. So delta W A to C, let's have it as it is. Now students, let us go ahead and let us substitute the values. So Q from A to B, okay, delta Q from A to B. From the question you can see it is 250, no? From A to B, can you see the gas absorbs 250 joule of heat, right? The absorption of heat from A to B. So substitute, that is 250. So 250 joules, okay, plus from B to C is also given in the question. See, 60 joules, right? So 250 plus 60 is equal to now 180 plus the change in work done from A to C. See, now we can directly find out. So now what is the, we need to find out what is the change in work done from A to C for the gas. So we get that when you simplify, when you subtract the things, so you will get 310 minus 180, right? 250 plus 60 is 310, okay, minus 180 comes this side, becomes negative, so 180 minus 180. So the answer is 130 joules. So the change in work done for the gas to move from A to C is 130 joules. The answer is, correct answer is option B, students. Okay, thank you.
इस क्वेश्चन में हमें गिवन है टू प्रोसेसेस ए और बी, जिसके लिए अगर क्यू ए और डेल्टा क्यू बी हमारी अमाउंट ऑफ हीट एब्जॉर्ब्ड है और डेल्टा यू ए और डेल्टा यू बी चेंज इन इंटरनल एनर्जी है, तो हमें रिलेशन बतानी है क्यू ए क्यू बी और यू ए यू बी में क्या रिलेशन होगी। तो देखिए, जो हमारी चेंज इन इंटरनल एनर्जी होती है वो सिर्फ इनिशियल एंड फाइनल पॉइंट्स पे डिपेंड करती है। तो हम लिख देते हैं जो डेल्टा यू है डिपेंड्स ऑन ओनली इनिशियल एंड फाइनल पॉइंट्स, ठीक है। और हमें पता है कि यहाँ पे दो ए प्रोसेस हो या पॉइंट्स, ए प्रोसेस हो या बी प्रोसेस हो, दोनों के लिए हमारे इनिशियल एंड फाइनल पॉइंट सेम है। तो इसका मतलब जो डेल्टा यू ए है वो इक्वल हो जाएगी डेल्टा यू बी के, ठीक है। अब हम वर्क डन देख लेते हैं। हमारा वर्क डन क्या होगा इन प्रोसेस ए। देखो, वर्क डन जो होता है वो होता है एरिया अंडर द कर्व, ठीक है। हमें पता है कि एरिया अंडर कर्व ए जो है वो बड़ा है एरिया अंडर कर्व बी के। एरिया अंडर कर्व ए जो है वो ग्रेटर है एरिया अंडर कर्व बी के। तो हम क्या कह सकते हैं कि जो वर्क डन ए बाय ए है वो ग्रेटर होगा डेल्टा डब्ल्यू बी के, ये होगा। तो हम फर्स्ट लॉ से कह सकते हैं, क्या होता है फर्स्ट लॉ, डेल्टा क्यू इज इक्वल्स टू डेल्टा यू प्लस डेल्टा डब्ल्यू। जिसका वर्क डन ज़्यादा होगा उसी की डेल्टा क्यू ज़्यादा होगी। इसका मतलब डेल्टा क्यू ए प्रोसेस के लिए ग्रेटर होगी डेल्टा क्यू बी से। तो हमें ये 2 पॉइंट्स मिल गए कि डेल्टा यू ए डेल्टा यू बी के इक्वल है और डेल्टा क्यू ए ग्रेटर देन है डेल्टा क्यू बी से। ये सेकंड ऑप्शन में दे रखा है, तो हम यहाँ लिख सकते हैं सेकंड ऑप्शन इज करेक्ट और ये क्वेश्चन सॉल्व हो गया हमारा, ठीक है।
Hello, welcome guys. So in this question, we have to find the work done through this graph. So this is the process from C to A to B, and then from B to C. So we can see that this is a cyclic process. So we have to find the work done in this cyclic process. So work done whenever we have been given a graph between P and B is equals to area under that curve. So area of this curve is, since this is a triangle which is of right angle, so area of this triangle can be written as half into, this is P value, so this will be your P value and this is your V value. So we take P into V. So this will be our work done. I repeat that whenever a graph between P and V is given and we have to find the work done, so we have to calculate the area surrounded by that curve. So this is the area. So calculating this, we have P value as, so this is 1 here, so 1 here and 6 here. So the length is 6 minus 1, so this is 5 Pascal. And since this length is from C to A, C to A, C is 1 and A is 5. So this is 4 meter cube. So this will be half into 5 Pascal into 4. Since all of these are in SI units, so this will comes out to be in Joule. So we can tell that our work will be 10 Joule. And since see that our process is clockwise, so for clockwise process, we take the work value as to be positive, and for anti-clockwise, we take our work as to be negative. Since the work is in clockwise direction, so we will take our work as positive. So this is the work done. Thank you.
We have a question is that a rigged diatomatic ideal gas undergoes an adiabatic process at room temperature. The relationship between the temperature and the volume of the pressure in T V to the power x. So x is the constant. So we find out the value of x. So for the adiabatic process, for adiabatic process, T V to the power gamma minus 1, that is equals to the constant. Okay, and for the diatomatic process, we know that gamma minus 1. So gamma value having the 7 by 5 minus 1. So the value of x, that is equals to the 2 by 5. So the answer of this question is 2 by 5. And thank you for the work.
Hello everyone, the question says that half mole of an ideal monatomic gas is heated at constant pressure of 1 atm from 20 degrees Celsius to 90 degrees Celsius. Work done by gas is close to. Gas constant R is 8.31 joule per mole per Kelvin. Now we will write, we have given number of mole is half mole of an ideal monatomic gas. So N is half mole of ideal monatomic gas is heated at constant pressure of 1 atm. So pressure is 1 atmospheric pressure from 20 degrees Celsius to 90 degrees Celsius, that is change in temperature. So change in temperature is 90 minus 20 degrees Celsius, that will be equal to 70 degrees Celsius. So now in this question I have to find out the work done by gas. So pressure is constant, so pressure is constant, it means it is isobaric process. So for isobaric process, work done is, that is equals to P delta V, that will be equal to N R delta T. Now substitute the value. Number of mole is N upon 2, R is 8.31 and change in temperature is, so change in temperature is 70 degrees Celsius. So we will convert this temperature into Kelvin because value of universal gas constant in Kelvin. So it will become 70 plus 273. So now we get 1 upon 2 into 8.31 into this will become 343 Kelvin. Now on solving this equation we get work done is 1425.165 joule. So it is our required work done.
Hello everyone, let us start with our question. In this question, what is given? A gas in an enclosed is enclosed in a cylinder with movable frictionless piston. Now initial thermodynamic state are given as to be pressure is 10 to the power 5 and volume is 10 raised to the power minus 3, and final pressure is given as to be 1 by 32 into 10 raised to the power 5 and final volume is 8 into 10 raised to the power minus 3. Now in an adiabatic quasi-static process, P cube V to the power, so it is V to the power 5. This is equals to constant. Consider another thermodynamic process that bring the system from the same initial and to the same final step, okay, in the two-step ways. Now in this process, so one is the adiabatic process. Another thing is that we are going through the same process which the adiabatic process goes, but in a two-step, okay. One is the isobaric and then followed by the isochoric process. We need to find the total amount of energy which is supplied, okay. So what is the situation? So if we just draw our indicator diagram, our PV diagram, so let's say this is our pressure axis and this is our volume axis. This is our pressure, okay, this is our P, this is our V. So what is happening? So initially we are following a adiabatic process. So this is the curve of adiabatic process. Okay, this is the adiabatic process in the indicator diagram. So these are the initial state and this is the final state. So this is the one-step process. Now what we do, we just go from initial to the final in two-step way. First we go in a isobaric and then we follow the isochoric process. Okay, so let's assume this is our process 1 and let's say this is our process 2 and this is our adiabatic process. Okay, now in the adiabatic process, what is Q? We know that Q value would be equals to 0. Q is 0. And what is the process equation which is given? It is given as to be P cube V to the power 5. This value is equals to constant. If we take the cubic root of this expression, so what we can write? We can write P V to the power 5 by 3. Here also we take the cubic root, but the cubic root of a constant would again be some constant. Now if we compare this with our standard equation, P V to the power gamma equals to constant, what we get? We get gamma as to be, for the process, it would be 5 by 3. Now, for an adiabatic process, this is the adiabatic process. If we apply first law of thermodynamics, then Q minus W would be equals to delta U. Now, for an adiabatic process, this would be equals to 0. That means our change in internal energy would be equals to negative of the work done. Okay. Now, what is the work done in case of an adiabatic process? We know that work done would be equals to PV in the final minus PV, product of PV for the initial, divided by 1 minus gamma. So we need to substitute the value. So initial condition of pressure volume we know, final this initial condition of pressure volume we know, final condition we know, we can just put the values. So if we see here, we have been given with the final values of pressure volume, initial values of pressure volume. So if you put, then our work done would turn out to be, so the final is given as to be this pressure 1 by 32 into 10 raised to the power 5. This is the pressure, and volume is 8 into 10 raised to the power minus 3. Minus initial pressure is 10 raised to the power 5 into initial volume is 10 raised to the power minus 3. Now this whole term divided by 1 minus gamma. So we take divide this by 1 minus gamma. What is the value of gamma which we have calculated? 5 by 3. Now if we solve this, then our work done would turn out to be 112.5 joule. This is the work done. So what is the change in internal energy? Change in internal energy would be negative of this value. So it would be minus 112.5 joule. Okay. Now if we see for the two-step process, now for the two-step process, this is the initial state and this is the final state. So for the two-step process, we are going from the same initial location to the same final location. So internal energy just depend on the initial and final state. That means for the two-step process also, our energy delta U would be same. So we just write for the two-step process, for two-step process, our delta U would remain same, which value is minus 112.5 joule. Okay. Now if we apply our first law of thermodynamics, what we can say that Q net would be equals to W net plus delta U. So since it is a two-step process, so we can say that our Q net would be Q of first process plus Q of second process. It is equals to work of first process plus work of second process plus delta U. Now we need to find this value. Okay, what we know delta U. Now W1 and W2, if we see from the figure, this is the isochoric process. So work done in an isochoric process is 0. We can say that this term would be equals to 0. Now W1, this is an isobaric process. So what is the work done in an isobaric process? Work done in an isobaric process, we just write here, it is equals to pressure, the constant pressure multiplied by the change in volume. And change in volume we know final minus initial. So we can put the value. So our W1 would turn out to be, so we just write here our Q net, this would be equals to W1 would be pressure times volume. So pressure is given is 10 raised to the power 5, and this change in volume would be final volume, it is 8 into 10 raised to the power minus 3, minus initial volume would be 10 raised to the power minus 3, plus we need to add this value, delta U is minus 112.5, minus 112.5. So if we solve this, then our Q1 would plus Q2 would turn out to be 587.5 joule. This would be the value of Q net. So if we check which of the option is the correct option, QNet. So the closest option is 588. So the correct answer would be our C option. Hope you understood the solution. Thank you.
Hello everyone. So the question is 1 mole of a diatomic gas undergoes a cyclic process ABC as shown in the figure. The process BC is adiabatic. The temperature at A, B and C points are 400 Kelvin, 800 Kelvin and 600 Kelvin respectively. Choose the correct statement. And all statements are about internal energy. So we have to find out the internal energy for the whole cycle, for the CA process, for the AB process and for the BC process. Now we know that my internal energy is a state function, and state function means delta U is a state function, and state function means it does not depend on the path but only depend on the initial and final state. And for a cyclic process, my initial state is equal to the final state for cyclic process, and this is a cyclic process. It is cyclic. Okay, I'll wrap this. Initial state is equal to the final state for the cyclic process, and my ABC process is cyclic process, so my delta U for this whole cycle will be 0. Delta U cycle equals to 0 because initial state is equal to the final state. Okay, now we have to find out the internal energy for AC process. Okay, internal energy for AC process, delta U for AC process, and internal energy is given by the formula NCV delta T, where Cv is the molar heat capacity at constant volume, and the value of Cv for diatomic gas is 5/2R for diatomic gas. Now putting the values 5/2 and R, delta T is Tc minus Ta, and temperature at point A, B and C given in the question. So putting the values 5/2 and R, temperature at point C is 600 and at point A is 400. So it's 400 and point AC. At A it's 400 and at C is 600. Okay, 600 minus 400, so it is like 5/2 into 1 mole into R into 200, so it is 100, it is like 500 R. This is my delta U for the AC process. Similarly, we have to find out the internal energy for the AB process. Okay, so internal energy for AB process is given by N Cv delta T is Tb minus Ta. Now putting the values 5/2 into N into R, temperature at point B is 800 and point A is 400, so it's 800 minus 400, 800 minus 400, so it is like 5/2 R into 400, and it is 200, so it is 1000 R. This is the internal energy for the process AB. Similarly, the internal energy for the BC process. Okay, so the internal energy for the last process, which is my BC process, it is given by N, which is 1 into Cv, which is 5/2 R, and the temperature Tc minus Tb. Okay, so it is 5/2 R Tc. Tc is 600 and B is 800. Okay, so 600 minus 800, So it is minus 200, so minus 5 by 2 into 200 R. So it is minus 500 R for the BC process. So now I have the internal energy for all of the processes, which is AB, BC and AC process. Okay. Now let's check the statements. The statement first is the change in internal energy in whole process is 250 R, which is wrong statement because the change in internal energy for the whole cyclic process is 0. So it is wrong statement. Second is the change in internal energy in process CA is 700, which is also wrong. The change in internal energy in the process AB is 350 R, which is also wrong. And the change in internal energy in the process BC is 500 R, and for the BC process is it minus 5000 R. So it is also not correct. So all of my statements are not correct. Okay, thank you.
Hello everyone. So the question is, the given PV diagram represents the thermodynamic cycle of an engine operating with an ideal monoatomic gas. Okay, so the gas given in the question is monoatomic gas. The amount of heat extracted from the source in a single cycle is, we have to calculate the extracted heat from the source, that is the positive heat. So let's start the solution. In this PV diagram, as you can see, suppose this is my cyclic process A, B, C, D, A. This is the cyclic process. So in process AB, as you can see that my pressure is constant. As you can see in the diagram, my pressure is constant. That means this is my isobaric process. And for isobaric process, the heat is given by, so the heat in this process AB is given by NCP dt or delta T. Because pressure is constant, so we write Cp. Cp is the specific heat at constant pressure. Now in the gas, they are saying that my gas is monoatomic, and for monoatomic gas, the value of Cp and Cv will be, Cv is 3 by 2 R for monoatomic gas, and the value of Cp is 5 by 2 R. Okay, so these are the values for monoatomic gas. Now putting the values, I will have delta Q for AB process, that is equals to N 5 by 2 R delta T. Now from ideal gas equation, I know ideal gas equation is PV equals to nRT. Okay, PV equals to nRT. From here, the value of T will be PV upon nR. So I can write my heat, that is delta Q for AB process, that is equals to 5 by 2 nR. Delta T is, the process is A to B, so delta T is TB minus TA. Now I can write TB as PVVV upon nR from ideal gas equation. Okay, so it is PBVB upon nR minus PAVA upon nR. Now nR is common, so nR is cancel out. Now I will have delta Q for AB process, that is equals to 5 by 2. Now pressure and volume at point V, as you can see in the diagram, pressure is 2P naught and volume is 2V naught. So total is 4P naught V naught. Simple. Minus PAVA, pressure at point A and volume at A. So pressure is 2P naught and volume is V naught. That means 2P naught V naught. Now delta Q AB will be 5 by 2 into 2P naught V naught. 2P naught V naught, 2 cancel out. So it is 5P naught V naught. Now this heat is in positive. That means this heat is extracted. Heat is extracted. Now the second process, okay. Second process is BC process, and in BC process, as you can see, my volume is constant. So for BC process, in B2C process, volume is constant. That means volume is constant means isochoric process, and for isochoric process, the heat is given by the formula delta Q for BC process, that is equal to NCV delta T, where CV is the specific heat at constant volume. Now I already told you that the value of CV for monatomic gas is 3/2R. So putting the value delta QBC equals to 3/2 NR. Delta T is Tc minus Tb. Now similarly, from ideal gas equation, I can put in the place of Tc and Tb as 3/2 NR PCVC upon NR minus PVVV upon NR. Okay, now NR cancel out. Now value of pressure and volume at point C. What is the value of pressure and volume at point C? In the diagram, at point C, the pressure is P naught and volume is 2V naught. So I can write 2 P naught V naught. Okay. Minus pressure and volume at point B, that is 2 P naught and 2 V naught. So I can write 4 P naught V naught. 4 P naught V naught. So the value of heat for this process will be delta QBC equals to 3/2 minus into 2 P naught V naught. Now this heat will be in minus 3 P naught V naught, and this minus sign represents that heat is absorbed. So we are going to neglect this heat because we have to calculate only the extracted heat, and this heat is absorbed. So we will neglect this heat. Now the next process is process C2A. Process C2D. In C2D process, the pressure is constant. That means isobaric process. And for isobaric process, I already told you that the heat is given by NCP dt. Okay. In CD process, pressure is constant, means isobaric process. And for isobaric process, the heat is given by NCP delta T, and the value of Cp is 5/2 R. So 5/2 N R delta T is Td minus Tc. Putting the values from ideal gas equation, similarly I will have 5/2 NR PdVd upon NR minus PCVC upon NR. NR cancel out. Now I will have 5/2. Now pressure and volume at point D. At point D, you can see the pressure is P naught and volume is V naught. So it is P naught V naught. P naught V naught. And at point C, pressure and volume is 2 V naught and P naught. So it is 2 P naught V naught. Now this value is in negative. That means the heat is minus 5/2 P naught V naught. Heat is in negative. That means heat is absorbed. So we also neglect this heat because we have to calculate only extracted heat. Now the last process is D2A process. Okay, the last process is D2A process, and in D2A process, volume is constant. Volume is constant. That means isochoric process, and in isochoric process, the heat is given by the formula delta Q. For DA process is written as NCV delta T. Now putting all the values, it is 5/2 NR, and NR cancel out. So I will write directly 5/2 for D to A process, that means PAVA minus PD VD. Simple. Upon NR, and outside the NR cancel out. So I will write this directly. Okay. So it is 5 by 2. Now pressure and volume at point A is 2P naught and V naught. So it is 2P naught V naught, and pressure at point D is P naught V naught, P naught V naught. So it is 5 by 2 P naught V naught, and this heat is in positive. That means this heat is also extracted. Heat is extracted. Now we have to calculate the total heat extracted in this whole process. So total extracted heat, that is equal to the heat in AB process, which is in positive, and heat in DA process, that is also in positive. Heat in AB process is 5 P naught V naught. Okay. Oh, I will put the value of CV is wrong. This is 3 by 2. Okay. Let I correct this. This is, I'm sorry, it's 3 by 2. Value of CV is 3 by 2. So here it is 3 by 2, 3 by 2 and 3 by 2. Okay. Okay. So 5 P naught V naught plus 3 by 2 P naught V naught. So the total heat extracted is 13 by 2 P naught V naught. This is the answer. Okay. So let's check the options. The second option, which is 13 by 2 P naught V naught, is the correct answer. Okay. Thank you.
In this question, we can see that 1 mole of the monoatomic ideal gas is taken along the 2-cycle process. We can see EFGE and EFHE process. We can see as shown. We can see in the PV diagram. The process involved are the purely isochoric, isobaric, isothermic, or adiabatic. We can see clear. Now, match the path in the first list. First, we can see with the magnitude of the work done in the list 2. We can see, and select the correct answer in the code given below in the list. Clear. Now we can see that list 1 and list 2 we have, so we have to choose the correct in the list 2 for the list 1. We can say clear. Now we have to find the volume at H and volume at G we have to find. So this is what we can see isothermal process, and this is what we can see adiabatic process. Clear. This is what adiabatic process. Why this is? Because as we know, slope of the adiabatic process should be greater than the slope of the isothermal process. So we can write here slope of adiabatic process should be greater than the slope of isothermal process. This we can see clear. So on the basis of this, we can see this is what isothermal process and this is what adiabatic process. Clear. Now how we can find the Vg and Vh? Clear. So we can see from here for FH we can write, for FH process we can write this. For FH we can write this is what adiabatic process. So we can see from here PV to the power gamma equal to constant. So PV to the power gamma equal to what? Constant. We can see from here. Clear. Now P is what we can see. For F and H we can see P is what? 32 into P naught, and V naught to the power gamma is equal to, we can write P naught, and we can write this is what? VH to the power gamma. Clear. And the gamma is equal to, in this case, monoatomic gas. So this is equal to, gamma is equal to, we can write here, this is equal to 5 and divided by this 3 we can write. Clear. Now this is equal to 32 and P naught we can write V naught to the power 5 by 3 we can write is equal to, we can write P naught and VH, and we can write this 5 by 3 we can write. Clear. Now from here we can write this VH is equal to 8 into V naught we can write. Clear. So VH is equal to 8 into V naught we can write. Clear. Now for FG process we can write. So for FG process we can see from here this is what isothermal process. So we can write PV equal to constant. So PV equal to what? Constant we can write, clear? Now from here we can write, from the figure we can write 32 into P naught into V naught is equal to P naught into Vg we can write, clear? So P naught cancel out. So from here we can write this Vg is equal to 32 into this V naught we can write, clear? Now from here we can see that here is what 32 into V naught and here is what we can see 8 into V naught, this, clear? Now in the list first we can see in the P part we can see work done in GE process we have to find, clear? So how we can find the work done in the GE process? So in the P part we can see we have to find the WGE we have to find, clear? This. So this WGE is equal to, we can use this P del V we can use, clear? So P into del V, clear? So pressure, this is equal to P naught and del V we can write from here. This is what V naught and minus 32 into V naught, clear? So this is equal to minus 31 this P naught into V naught. So this is equal to what? Magnitude we have to take. So magnitude of this is equal to what? So from here we can write magnitude is, this is equal to 31 P naught and V naught, clear? Now according to list 2 we can see this 4, clear? So we can match this with the 4 we can match. Second we have to find the work GH, clear? So in the Q part we can see we have to find WGH we have to find, clear? So how we can find the WGH? We can see from here this WGH is equal to P naught we can write into, we can write 8 into V naught and minus 32 into V naught, clear? So magnitude of this work is done is what? 24 into P naught V naught we can see. Now according to list 2 we can see this 3, clear? So we can match with the 3 we can see from here, clear? Now FH we have to find. So in the R part we can see FH we have to find, clear? So this process we can write W this FH, clear? So this is equal to, we can see that N R into del T, this, and divided by 1 minus gamma we can write this, clear? So this can be written as PH and VH we can write, and minus we can write PF, and the VF we can write, and divided by we can write 1 minus gamma we can write this, clear? So this is equal to P naught into 8 V naught minus we can write 32 P naught into V naught and divided by we can write 1 minus 5 by 3 we can write this, clear? Now this is equal to, after solving this we will get this is equal to 36 P naught and V naught, clear? This. Now according to list 2 we can see this 2, clear? So we can match with the 2 we can see. Now in the S part, in the last part we can see from here we have to find the work done FG process, clear? So WFG we have to find, clear? This. So how we can find the WFG? For this we have to use nRT, and this is what ln, and this is what Vg we can write. This is Vg and divided by we can write this is what Vf, clear? Vg by Vf we can write. So this is equal to what? nRT ln we can write, and Vg is what we can write 32 into V naught and divided by we can write V naught, this, clear? Now so from here we can see that, so how we can find T, clear? So how we can find the T? So T is equal to, we can see from here 32 and P naught V naught and divided by this 1 into R we can write this, clear? For 1 mole this is equal to what? 1 into R. So this T value we have to put here, clear? So if you put T value here, so we can see nR into 32 into P naught V naught and divided by we can write R, clear? And this is what? This V naught and V naught cancel out to each other. So ln 32 we can write, clear? So this is equal to this R and R cancel out to each other. So we can see from here this n into P naught V naught and this ln 2 to the power 5 we can write. Clear? Now as we know that ln a to the power b is equal to b and ln a we can write. Clear? This. Now from here we can write this 32 is also here. So 32 is also here. So this is equal to 160 we can write n into P naught V naught and ln 2 we can write. Clear? This. So this is the work done. Clear? Now according to second list we can see this first. Clear? So in this way we can solve this question. Hope this answered your question. Thank you.
Hello everyone. So the question is 5.6 liter of helium gas at STP, that is our standard temperature and pressure, is adiabatically compressed to 0.7 liter, taking the initial temperature to be T1. The work done in the process is, and they are giving the options too. Now the process is adiabatical. Suppose first I am going to write the given things. Okay. So the given things are, first the volume of the gas, that is V1 equals to 5.6 liter, and V2 is also given in the question. After adiabatically compression, the gas is compressed to 0.7 liter. So this is my final volume. STP is given in the question, that is standard temperature and pressure, and standard pressure is 1 atmosphere and standard temperature is 273 Kelvin. Okay, now in the question they are asking the work done in the process is. Now we know that the process is adiabatically, and in adiabatical process the work done is given by the formula nR delta T upon gamma minus 1. To calculate the work done, we must know the value of n, that is number of mole, the value of temperature difference, and the value of gamma. Now in the question they are saying that my gas is helium, and we know that helium is a monoatomic gas, and for monoatomic gas the value of gamma is 5/3. Now one more thing which I know, that at STP my 22.4 liter is equal to the 1 mole. Okay, at STP my 22.4 liter gas is equal to the 1 mole. So my 5.6 liter gas is equal to the 22, sorry, it's 5.6 upon 22. Simple. So it's like 5.6 upon 22.4, and it is 1/4 mole. Now I am having the value of n and the value of gamma. Now I have to know the value of temperature. Now I know that the pressure, that the process is adiabatically, so the relation between the temperature and volume is given by the equation Tv gamma minus 1 equals to constant, and this equation is applicable for the initial condition as well as final condition. So for final condition, T2 V2 gamma minus 1 equals to initial T1 V1 gamma minus 1. From here my T2 is coming out to be V1 upon V2 gamma minus 1, and the T1. Now I am going to putting the values of V1 and V2. The value of V1 is 5.6, the value of V2 is 0.7, the value of gamma is 5/3 minus 1 T1. After solving this is like my 8 power 2/3 T1. This is T2. Okay, T2 equals to, and after solving this finally I have my temperature at final condition, and this is the 4 times of initial temperature. Okay, now I have my initial temperature and final temperature, so I can calculate my temperature difference. Temperature difference is basically final temperature, that is 4T1 minus initial temperature. So my delta T, that is change in temperature, is 3T1. Now I will calculate my work done because I have all the values. My work done is nR delta T upon gamma minus 1. The value of n is 1/4 mole into R. Delta T is 3T1 and the value of gamma minus 1, it is 5 by 3 minus 1. After simplifying this, I will get my work done as 9 by 8 RT1. This is my work done for this process. Now check the options. In the first option, which is 9 by 8 RT1 is our correct answer. Okay, thank you.